Hello and welcome to another genetic algorithms video. In this video, I want to talk about something called pool selection based on fitness. And actually this video is inspired by a comment that came in on GitHub from Sinclair ZX81, who writes, "Thanks for the video regarding genetic algorithms. In this video, you suggest an algorithm for pool selection based on fitness." Now, if you remember, what was my algorithm? My algorithm was, I have a bunch of elements in a population like A, B, and C. They each get a fitness score, like a fitness score of 8, a fitness score of 2, and a fitness score of 1. And what I do is I create a pool, a mating pool, not a swimming pool, or it's not any of these things, it's just some computer thing, which is an array. But essentially, I create that pool, and I put A in 8 times. A. I put B in twice, and I put C in once. So the amount of times they're in the pool is relative to their fitness function. And then if I go and say magically, pick me a random element from that pool, I am 4 times as more likely to pick A over B, I'm 8 times as more likely to pick A over C, et cetera, et cetera. So you can see how their fitness, in this case, maps to probability. But this solution is not the greatest solution on Earth, or in the universe, or whatever. And the reason for this, as Sinclair writes, is the method you described involves populating a large array of elements. And this can actually, you might have noticed while I was doing the Smart Rockets coding challenge, like there was a lot of stuttering at the end of the generation. So this can really be a problem. Suddenly I made this array that has like 100,000 or 1,000,000 elements in it, and things can run really, really slow. So Sinclair suggests a different approach for selection, a bit more generalized, and supports arbitrary fitness values and should be fairly quick. So I encourage you to look at Sinclair's code. I'll link to this GitHub issue thread. But a lot of this code uses sort of advanced JavaScript array functionality stuff, which is kind of beyond the scope of what I'm doing. So I'm going to try to implement this strategy that Sinclair outlines in a sort of simpler way, perhaps less efficient, but I'm going to try to do it in this video. Now, what this strategy is also referred to as, often referred to as rejection sampling or accept-reject algorithm. And this is a kind of Monte Carlo method. I always just, if anytime I could say Monte Carlo, I'd like to say Monte Carlo. And if I could just leave and go have some, anyway, I don't want to talk about gambling in Monte Carlo. There's no reason for that. Let me come back over to the whiteboard. And so let's talk about how this algorithm is different. What if I could pick, so in this case, I'm picking a single random number, an index into this array. What if we forget about this giant array thing? And what if I were to just pick A, B, or C? I would be picking, if this were an array, 0, 1, or 2, right? I would be picking a random value, 0, 1, or sorry, between 0 and 3. And I would say floor. So what that's going to give me is this function is going to give me 0, 1, or 2. So if I do that, if this is all I do, then, and this should be a 1 up here, if this is all I do, then I have a 1/3 chance of picking A, a 1/3 chance of picking B, and a 1/3 chance of picking C. This will not do, because I want to have a higher probability of picking A, a medium probability of picking B, and a lower probability of picking C, scaled according to their fitness. So let's think about what I mean by accept reject. So I'm still going to do, this is going to be a 2-step process. Step 1 is going to be this, pick A, B, or C. Now though, step 2, with an equal probability for each, accept or reject. That's the question I need to ask. I picked 0, 1, or 2, but am I going to accept that as my pick, or am I going to reject it and try again? And here's a way I could do that. What if I also picked a random number between 0 and 10? And if that random number happened to be less than the fitness score, then I'm going to say accept. If it is not less than the fitness score, I'm going to say reject. Right? And you can think about how this might work. Pretty often, if I pick a random number between 0 and 10, that's pretty often going to be less than 8. But very rarely going to be less than, rarely going to be less than 1. Or only 10% of the time it's going to be less than 1. But 80% of the time it's going to be less than 8. So you can see how this idea, and if I accept, then I keep it and I use that parent. If I reject it, then I go back and pick again. So I might have to do it multiple times per pick. But in the end, I'm going to have a way of mapping the fitness values according to, mapping the probability of picking an element according to its fitness value. So this is the theory behind it, and let's go try to implement that in code. Okay, so coming back over here, I want to show you something. I actually have a processing example that I will link to the source code for this. And before I get to the genetic algorithm, I'm just going to run this example. And what this example is doing right now is it's picking random numbers between 0 and the width of this window, and it's graphing the distribution of how often they've been picked. And look at that. I'm getting kind of an even distribution from and it's kind of normalizing them to the height of the window. It's doing all this stuff. So you can see over time, a good random number generator should pick an even distribution of numbers across the spectrum of what you're picking. But I'm going to now change something really quickly in the code, and I will and run it again. Now look at this distribution. So this is now a program that's picking random numbers between 0 and the width of the window, but it's much more likely to pick higher numbers than it is to pick lower numbers. And you can see this graph is actually just a linear graph of like y equals x. And how is that working? Well, I have this function called acceptReject. And notice what it does is it picks two random numbers. Why am I casting it? I must have written this at one point in like Eclipse or something, because it's totally unnecessary I don't know why I have that there, that extra, it still works. You can see that it picks two random numbers. And what it does is it says, and this really, I'm going to change this variable name, like probability. The probability whether or not we should accept random number 1 is equal to random number 1. So the higher random number 1 is, the higher its probability. And then I just check, was R2 less than the probability? If it was, return that value. Otherwise, go back and pick again. And I have this like goofy little thing here, this hack, where I'm like, if for some reason I tried to pick a random number 10,000 times and I didn't get anything, then something is going wrong, and let's at least get out of here and not like be in an infinite loop. But you can see how this code kind of works. So what I want to do now is try to take this same idea and bring it into the genetic algorithms. But rather than have the probability be based on the random number itself, right? I want the probability to be based on the fitness of that particular element. OK, so I'm going to go back. I'm going to leave processing. And I'm going to go back to JavaScript. And I'm going to look for this natural selection function. So let me just make sure. I'm going to hit save. This is the example that I'm running. It's this to be or not to be. That is the question example, which is trying to evolve to be or not to be. And I'm going to go back to here, where I'm creating this mating pool. So I am now going to get rid of this mating pool. Zonks. Goodbye, mating pool. OK, so I'm going to keep this maximum fitness. You're going to see that I'm going to use it in a second. But I don't need this whole thing where I build this extra mating pool. And in fact, this whole function is kind of irrelevant, except for this maximum fitness value. So I'm actually just going to take this out and do this maximum fitness thing in the generate function. So right here, this is the issue. I need to replace this part of the code. This is the part of the code where I pick parent A and parent B as an index into that particular mating pool. But I don't want to do that anymore. Instead, what I want to say is, I'm going to just have another function. I'm going to say acceptReject something in the population. I need to pick a random element in the population, and I also need to know, I need to pass in that maximum fitness will be a value. I need to write a new function called acceptReject. And you know what? It can just be in this object. So I think it'll be nice to encapsulate this in another function rather than write the code here, especially since I have to do it twice. So I'm going to write this down here now as, oops. This dot accept, and I forgot. Oh my goodness, never mind. I was trying to use my soundboard. I'm going to write a function called acceptReject. Okay? And what I want to do is the first thing I want to do is pick a random index. So I need to say random number between 0 and this dot population dot length. And the 0 is kind of an optional argument that I don't need. So I need a random number between 0 and the length of the population. And I want to floor that. Then what I need to do is pick another random number. I'm just going to call that R, which is a random value between 0 and maximum fitness. So I want some value that goes between 0 and the maximum fitness. if R is less than, oh, sorry, if, okay, so now, sorry, the member of the population, the partner, the parent, is this dot population index. So this is the actual partner that I picked. So I'm picking a random element from the population. This is kind of, and then I want to get like that, the index into the array, and then I want the actual object itself. Because what I want to test is if that partner's fitness is less than R. Let's think about this. No. If R is less than that partner's fitness. Let's think about this, right? If the fitness values go between 0 and 100, I'm picking a random number now between 0 and 100. If the partner, if this particular element has a fitness value of 100, the random number is always going to qualify. I'm always going to accept it. If it has 50, it'll be 50% of the time. If it's 25, the fitness is 25, it'll be 20% of the time. And I can say return that partner. Otherwise, what? Do it again. So I want to say while, I'm just going to do this, while true, over and over and over again. The return will get me out of this function. So this accept reject strategy is going to always pick a random population, member of the population, pick a random number, and if it qualifies, if it should be accepted, return it. I'm forgetting some this dots, people are telling me in the chat. Line 51 and 52. Yep, thank you. So now this should be this dot accept, this dot reject, this dot accept reject. Okay, so the other thing I want to do is I'm just going to say be safe. Be safe equals 0. Be safe plus plus. And if be safe is ever greater than 10,000, return null. I don't know what this is really doing, but I just want to like get out of that infinite loop. Like I feel like something's wrong if this takes 10,000 times to find a correct value. So let's look at this and let's just see. I don't know, how did I do? Let's run this. Okay, so clearly I'm getting an error. The error is population.natural selection is not a function. Right, I eliminated an entire function from this particular scenario. Sketch.js line 40. So I'm going to go to line 40. And I'm going to delete this function. Doesn't exist anymore. Max fitness is not defined So I'm back after a little bit of debugging. I had some sort of significant issues. You can see right now what's happening is I'm not kind of getting any evolution. There's a couple reasons why this is happening. Number one is that the fitness function that I'm using, at the beginning, when I pick a lot of random phrases, a lot of them don't have any correct characters. And I'm getting a fitness function of 0. And in this new algorithm that we've designed, if the fitness value is 0, this thing has no chance ever of being picked. Because I can never pick a random number between 0 and something that's less than 0. So as a little bit, this isn't the best solution, but as a little bit of a hack, I'm just going to, in the fitness function, add 0.01. So I can, at a minimum, the fitness function is 0.0, the fitness value is 0.01. So everything has at least like a 1% chance of being picked according to this rejection sampling model that I'm now using. But there's another significant problem, and I could run this. I could run this again now. And it's sort of doing some stuff now. It's going to break here and there or do weird things. And it's not really evolving very well. There's also a major issue. If you notice in the code, if I go back to this code, this is what I'm doing. And the comment says it all. Refill the population with children from the mating pool. So what I was doing before is I had a separate array that I was pulling from to create child objects to put in the population. But I'm no longer doing that. I'm now actually picking from the population to put things back into the population. But I can't be putting the next generation into the population while I'm continuing to pick the current population. So what I need is a whole separate array. I'm going to call this new population. And it's just an empty array. And instead of filling the existing population, I want to fill that new population. And then at the end, I can happily say this.population equals new population. So that is a fix that I also need here. And now I should be able to run it. And we should see that we're back to our old tricks again. We've got to be or not to be evolving. Now, it actually, I think there's going to be an issue because it got to be or not to be, but it's still going. There's a reason why it's still going, because I have a bit of code that says, somewhere I believe in the in evaluate here, yes. It says if the best fitness is equal to the perfect score, then you finish the simulation. The problem is the perfect score is 1, but remember I added 0.01 to it. So I'm just going to change this to if it's greater than or equal to. The perfect score being 1, 100% of the characters correct. But I'm just going to check if it's greater than that now because I added that 0.01 thing. So now we should run this again, and we should see this is doing exactly what we did before. So there's really, my assumption here is there's not a significant difference between the behavior of this version of the genetic algorithm and the one that I did with the building the large array mating pool. But using this accept-reject strategy, this rejection sampling strategy, I've done away with this giant array thing, which I think in a lot of scenarios can be a useful solution to use as well. So as an exercise, you might go and find the Smart Rockets example that I built in a previous video in the coding challenge and see if you can take that and apply this accept-reject algorithm. And in that one in particular, I know I was building this really big array, which was making it run kind of slow, and see if it runs faster with this algorithm. Okay? Thanks for watching this video.